To understand more about the use cases for Hadoop ecosystem, we're going to take a look at what's called CAP theory or CAP theorem. And you may have heard about this if you study databases in school, but it's kind of an interesting way to understand the different categories and classifications of databases. So the first aspect of CAP theory is the idea of consistency. And the concept is that there are certain database solutions that allow for very high data consistency. And another way to think about this is that the solution supports transactions. So an example of a transaction would be if you had two data modification operations and they were combined as a unit. So withdrawing money, for example, out of a savings account and then adding that money into a checking account. You would want both of those changes to occur successfully or neither. Otherwise, your data would be inconsistent. So certain classes of databases support strong consistency. The second aspect of CAP theory is availability. And another way to say that is uptime. So what this means is that you have the ability to make copies of the data so that if one copy goes down in one location, the data will still be available for some or all of your users. And the third aspect of CAP theory is partitioning. And another way to think about that is scalability. And what that means is that you can split your set of data across multiple processing locations or physical machines or virtual machines so that you can continue to grow the amount of data that you work with. Now, traditional RDBMS systems are known for having consistency and availability and for having some difficulty, as I mentioned earlier, at the highest levels of partitioning. What the CAP theory says is that database systems can really only meet two of the three aspects of CAP theory. So this is where Hadoop comes into play because, as I mentioned earlier, the data that's becoming available for businesses and other companies is growing larger and larger and larger. So partitioning and the complexities around partitioning and the expense is causing companies to look at database solutions that support that aspect, and maybe they don't have a need for the other two aspects to be as fully implemented. So you might be wondering where Hadoop fits in the CAP theorem implementation. As I previously mentioned, Hadoop is designed for scalability. Now let's understand a little bit more about how that implementation works in terms of partitioning. First of all, it's important to understand that by default, Hadoop is designed to run on commodity hardware. So cheap servers, really, really old servers, I see this very, very commonly. So by default, you can run Hadoop storage on these cheap servers. It's also designed for partitioning in that it makes 3 copies of the data by default. And if any of the copies become bad because the hardware becomes bad or corrupt, you can just pull that old hardware out. And then when you put the new hardware in, the Hadoop file system will automatically manage that copy process. This goes to another property of Hadoop, which is flexibility or availability. Because it runs on commodity hardware, you can scale a Hadoop cluster nearly infinitely. And again, if you'll remember back to where the HDFS file system came from, it really makes a lot of sense. It was designed by engineers at Google originally to index the entire internet. So it's infinitely scalable. And in fact, it's really interesting to think about some of the major companies that are using Hadoop in the United States right now. The number 1 user is Yahoo, and the number 2 user is Facebook. And these companies obviously have huge data sets, and they're taking advantage of the cost saving that they get, scaling all that data out on commodity hardware. And of course, they also want high availability because it's their business to be online and available all the time.